Hey everyone, welcome to Code Harmony. Today we are going to solve this question 8 to 7, making a large island. This question is based out of graph theory, and recently this question has been asked in Meta several number of times. Apart from Meta, Google, Amazon, Airbnb, Adobe are also asking this question. This question is marked as hard, but you will be able to easily understand the explanation. Let's have a look on the problem statement. We are given n cross n size binary matrix grid. And apart from that, we are also allowed to change at most 1 0 to be 1. Okay, this is the problem statement, and what we have to return the size of the largest island in the grid. But we have to apply the operation. They are also saying that an island is 4 directionally connected group of ones. Okay, it means if it is 1, it is a land. If it is 0, if it is a water, and apart from 0 and 1, we are not going to have any other item in my grid. Okay, for now, let's just forget about this operation. And now the question will become something like this. We are given a grid, and in this grid, we have to find the largest island area. Okay, largest island in the grid. So that question is becoming similar to the question which is number of island. Number of islands. It means you are given a grid which is representing land and the water portion, and you have to find me the largest number of, and you have to find the biggest area of any island. Okay, if I just do in this case, so how we usually do this kind of problem? We definitely know that we have to start from every land portion. If from any land portion, I have 4 possibilities. Either I can go right, up, left, and down. I will only go if I am encountering 1. So until I keep on encountering 1, I will just go in that direction, and I will capture or include that cell as a part of my current island. But in this case, we are having only 2 islands. So this island is there, and this island is not connected to any other land cell by these 4 directions. Okay, so this is one island, and this is going to be my second island. So we are having 2 islands, and the largest island is of size 1. Now let's try to apply the operation in this function. Now my operation is that at most 1 0 can be converted to 1. If that is allowed, what 0 I am going to convert? I will try to convert any 0 that is going to give me the same result. If I just convert this 0 to 1, now the island size, what is the new island size? If I just write a new array, new grid, it will be something like this, 1 1 1 0. This is the new state. And now if I tell you what is the island size, maximum island size. Maximum island size has now become 3. Initially it was 1, and now it has become 3 because we have applied this operation given in the problem statement. Okay, so this operation is going to give us some benefit that our area can be increased significantly. Not just by one cell, but yeah, we can improve it significantly. Why? Because in this case, if you try to analyze, you are merging 2 islands together, island 1 and island 2, and there is a cell in between. That cell was 0, and if I convert this cell to 1, we are just connecting these 2 islands. So whatever is the size of this island, size 1, whatever the size of this island, size 2, and this one cell. So size 1 plus size 2 is going to be my size of final island. Okay, so this is something I wanted you to understand. Now let's try to have a bigger example. 1 0 1 1 0 1 0. Let's say this is going to be my grid, and now in this case, first of all, you have to figure out all the islands. Okay, you have figured out all the islands, and now how we are going to store those islands such that we will be able to utilize that further. See, we are only concerned about the island size. Okay. So in this case, we have to capture the island and whatever is the size of the island. So size we can capture while doing the DFS. We do the DFS to capture any island, and using that DFS we can capture the size. And now what should be the identifier for island? For that we can do the coloring to the island. Let's say in this case, what is my first island? First island is yellow island. This is going to be my first island. It's a yellow island, and this yellow island is of size 4. Now let's come to the second island. Second island is going to be this one, green island. So in this case, yellow island is going to be of size 4 and the green island is going to be of size 3. So let's say if somewhere I am able to store this information. This is my key and this is my value. I'm going to have a unique key. Unique key is like every time, every island, I'm going to keep giving a unique color. And the value is the size of that island. So what benefit I'm going to get from this map? The benefit I will get from this map is something like, let's say when we have done the coloring. Okay, coloring we have done. See, in this case, we have to write the code. So when we are writing the code, we can't just write the yellow and green. So we'll just assign the integer number for the coloring. 0 is already utilized. 1 is already utilized. 1 is a land cell, 0 is a water cell. 2, 3, 4 onwards, these value we can use to the colors. So let's say yellow is 2 color, and the green is color 3. So this is the 3 color, this is 2 color. So it will look like this. This is my first island and this is my second island. Okay, now I have to apply the operation. See, we have captured the islands and we have captured the size. So what is the largest size? We already know what is the current largest element. But we have to utilize that operation as well. That converting any 0 to 1. And when we are converting any 0 to 1, that 0 can be added to any one of the island. Or in the best case, that 0 can connect 2 island together. If the 0 is connecting 2 island together, it means the size of the island, size of the resultant island is going to be significantly high. Now we have to apply this operation 0 to 1. So which 0 I need to change it to 1. So for that we can go greedy and we can just check for every 0. Let's say check for this 0. If this 0 is I'm going to convert to 1, this is going to contribute into the one island. This is not going to contribute into any island, and this is going to contribute to the second island. Second island size will go from 3 to 4. But now when I come to this 0 in the middle row, this 0 is going to contribute to the left island and the right island. It means when it is becoming 1, so all the left portion, right portion and this cell, that is going to be my answer. So the left island is going to give me 4 size. Current node has also become 1 and the right island is of size 3. The answer is 8. So 8 is my largest possible answer. Okay, so what I did here in this case, let's just capture the algorithm. First one is capture islands. You can say islands ID and size, or ID size, you can say color and size. Okay, in this map. Now once you have captured island, firstly try to understand what is the time complexity to capture an island. In this case, when we capture an island, we start the DFS call from the first non-visited land cell, and then we will just keep on visiting it, and then further I will just go to the next land cell and then keep on visiting that as well. If you are not able to understand it, then I would recommend go to this question first. Find the number of island using DFS. This video I am going to attach in the description below. You will just find that. So first thing is just capture the island. Capturing island, we are going to every cell at max 1. At max 1 means at max the grid size is going to be the time. So time complexity is order of grid size. And what is the grid size? Grid is of n cross n. It means order of n square. Order of n square is the size of the grid. And now what you have to do is you have to iterate over every zero. See, in this case, first zero, second, third, fourth I'm coming, and then I will capture the others, process the others as well. Whatever is the maximum, this all I already know the maximum. This is the maximum. So whatever is the maximum, I'm just going to capture that. So I'm going to iterate it over it again. Iterate over it again and then capture the largest island size. Iterate on all zeros and then capture maximum island size. Okay. So now what I have done is I am doing the marking. So in this case, when this zero is coming, on the left side it is 2. It means whenever the value is greater than 1, I am giving it as considering it as a color. So 2 is a color for the left island. It means whatever nodes in the left island, I am going to consider that. So map dot get 2, that is going to be 4. Now above it's a 0, ignore that. Down it's a 0, ignore that. And the right it is 3. 3 means another island. And get the size of that island. Size of that island is 3. So that is also going to be added. So in this way we are going to calculate what for all the 0 what maximum island size I am going to get if I convert that 0 to 1. Okay, so these are the two main steps. But this problem is marked as hard because whenever a problem is hard, it is going to have so many edge cases, corner cases, something like that. So in this case, these two approaches are going to work. Now let's try to have a look on the case where we are having this possibility of my grid. If the grid is something like this, but here in the question grid is n cross n, so just keep it n cross n to make it aligned with the given input. Okay, so if this is the grid, in this case, how many island do we have? We have only one island. And can we convert any 0 to 1? No, we cannot convert. So you can consider that if island count is equal to 1, then you can just check what is the size of that island. If the island size is equal to n square, that is size of the grid, it means that whole the grid is being occupied by that island and we cannot convert any 0 to 1. So that is island size is the maximum size that can be there. Now what about the other possibility? Let's say other possibility is something like this. Now island size is 3 and we are having only one island, but maximum island can go till 4. It means there are some cell remaining and those cell are water cell and those cell can be converted to land cell. But if the island is only 1, so it means only one cell contribution will be given to the island size. So island size is 3. So if I just convert this 0 to 1, it will be incremented to 1. So these kind of corner cases, when let's say the island is 1 and all the cell are occupied by the land cell, and when the island is something like this, one island, and that island cell is less than n square, something like that. These kind of possibilities you need to capture as your control statements. If else condition you have to put, but overall time complexity and space complexity will remain this. Time complexity is this. What about the space complexity? We are capturing the values in the hash map as well. So the space complexity will also be order of n square. So this is the time and space complexity. Now we'll have a look on the code. Now this is the Java code for the approach that we discussed. First step is identify the color of each island and store its sizes. To identify each island, we are going to iterate over the grid and see whenever there is a land, we are going to start my DFS, and then that is going to be the particular color, and after that DFS increment the color as well, and that island size is going to be stored in my map. We are having only these 4 directions, so this first iteration is for capturing every island along with the color and the size. These are just some edge cases. Now you have to try converting every 0 to 1 and see whatever is the possible largest island you are getting. So iterating over the grid again, and if that grid is water, only in that case you have to do something. This is the visited island. See, for every water cell you can check for the 4 direction again, left, right, top, down. There's a 4 direction. So if any one is the valid island, add the size of that island into it. And for every 0, the neighbor, if the neighbor value is greater than 1, it means that is some kind of color. Some kind of color means that is an island, and also that island is not visited. And then capture all the size, all the cells from that island, and this is my global variable to capture the maximum, and this is I'm going to return from the function. So yeah, that's the whole function, and this DFS function is something just calculating the island, number of island, just marking to a specific color. Specific color is just index, this IJ, and this is the color. Initially it is 2, and then 3, 4, 5, and so on. Let's submit the code. The code is working fine, and yeah, we complete the January challenge as well. Okay, if you have any doubt, you can comment down below. I will be happy to help. Okay guys, bye bye, thank you.